How many DFAs are possible with two states x and y where x is an initial state over the alphabet A, B. So for x and y there are two states and we have alphabet A, B. Then for A alphabet here can be two choices. For B alphabet here can be two choices. For Y, for A alphabet two choices. For Y, B alphabet here can be two choices. So total four choices for x and y. How? The transition for A and B from x state can be like this. X is the initial state, A, B. Y can be like this, x, A, B, y, x, A, B, y, x, B, A, y. So these can be the possibilities. So there are four choices for x. In the similar way, here we can clearly see that y is constant or y is not changing, but only x variation. We have seen only x variation but not y variation. So in the similar way, the y variation can also possible. Y variation can also possible. So we can see clearly that four choices for x and for y. So 16 variations are possible. Variations are possible. If the y will change, every time y will change. For 1 there are 4 conditions, for 2 there are 4 conditions, for 3 there are 4 conditions, for 4 are 4 conditions. So 16 variations are possible. 16 variations are possible. And two choices of making final state. Two choices of making final state. X, because x is an initial state, so maybe or may not be final state. So there are two choices. In the similar way for y may be final state or may not be final state. So two choices. So 16 into 4 is equals to 64. 16 into 4 is equals to 64. So total how many DFAs can possible? 64 DFA can possible. We can clearly see here there are four kind of variation for x, but there is no variation in y. So in the similar way for one state there can be 4 variation for y. In the similar way 4 variation for y. The similar way 4 variation for y. So there can be the possibility of 16, as we have discussed here, 16. But there is initial state is given as x, but final state is not given. So two choices can be possible for x. X may be or may not be. In the similar way, y can be final state or y cannot be final state. So two choices are possible. So total 4. So 16 into 4 is equals to 64. So total 64 number of DFAs are possible where we have two states x and y with alphabet A and B. These are the total 64 states are possible. But one more thing is also there. If initial state is not given, if initial state is not given, as we have given here that x as an initial state, x is initial state, Here it is given, but if suppose if initial state is also not given, then what will the possibility? We have two options. Initial state, if not given, then we have two options. Either it can be x or it can be y. We have two choices. So two choices we have. If initial state is not given, then we have two choices. We have to suppose either it can be x or it can be y. So two choices are there. So 64 into 2. So 128 DFA can be possible. DFA can be possible. So these are the possibility we are having. In the similar way, how many DFAs are possible? In the similar way, how many DFAs are possible if we have three states? We have three states, x, y and z, where x is initial state and alphabet is A, B and C. We have three state x, y and z, and x is initial state, and we have alphabet A, B and C. So how many choices we have? X, Y, Z, A, B, C. How many choices we have? 3, 3, 3, 3, 3, 3, 3, 3, 3. Because we have three alphabets with three states, that's why each we have 3 choices. So total 27. Here how many we have? As we have seen here, total 4 according to this. Each, because we have two alphabet, so for each state we have two choices. That's why we total 4 choices, 2 into 2. In the similar way, we have 3 choices, so total 27. 27. So 2 into 2 into 2 to the power 3 into 3 to the power 9. So total how many? It will be 3 to the power 9. 3 to the power 3, 3 to the power 3, 3 to the power 3. So total 3 to the power 9. Here, what is the possibility? That only initial state is given. Only initial state is given. Or we can say initial state is given x, but final state is not given. As here initial state is given but final state is not given. So how many choices we have? 4. We can make x as a final state, maybe or may not be. Y is a final state, may or may not be. So total 2 and 2, 4 choices. But here in the similar way we write like this. Final state, if final state is not given, obviously final state is not given here, only initial state is given. So for final state we have to make the choices. How we can make the choices? For x, for y and for z. Two choices are there, maybe or may not. So according to this 2 choice, for y maybe or may not be. So according to this 2 choice, and for z also maybe or may not be final state. So 2 choices. So initial state is given, so it is clear. But for final state, 2 to 2, we have always 2 choices for x, for y, for z. So 2 to the power 3, and from here 3 to the power 9. So how many states? So total, how many DFAs are possible? 1,57,464 DFAs can possible. If we talk about if initial state is not given also, here initial state is given, but if initial state is not given also, then we have three choices: X, Y and Z. If initial state not given, then we have three choices: X, Y and Z. So what we can do, we can multiply it. 157,464 into 3. So these many DFAs are possible. We can multiply it by 3 because we have 3 number of state. If initial state is not given, then we have 3 choices. So we can multiply it with 3. Then these many DFAs are possible.